Limits of piecewise defined functions. The key to calculating the limit of a piecewise function is to identify the interval in which the x value belongs. We can simply compute the limit of the function that is represented by the equation when x lies inside that interval. It may sound a bit tricky, but it's actually quite simple. Let's look at the next example to see how this is the case. Find the indicated limit of the piecewise function. F of x is equal to 1 over the quantity x plus 3 for x values less than -3. It's equal to x squared minus 12 for x values between -3 and +4, including +4. And it's equal to the square root of x plus 12 for x values greater than 4. And we are finding the limit of f of x as x approaches -11. Notice we have the limit of f of x as x approaches -11. Well, -11 is less than -3, so we're going to use our first piece of our piecewise function, and we can directly substitute -11 in for x. And when we do that, we get 1 over -11 plus 3, which equals -1/8. Now let's find the indicated limit of the same piecewise function, the limit of f of x as x approaches 1. To calculate this limit, we have to use the second section of our piecewise function, or the second piece, because x approaches 1, 1 is within this section of the domain. So let's substitute 1 in for x in this expression. When we do that, we will have 1 squared, which is 1, minus 12, which is -11. Find the indicated limit of the piecewise function. Same function, but now we're taking the limit of f of x as x approaches 24. Notice that the c value of our limit of 24 lies within the last section of our domain for this piecewise function. So we're going to substitute 24 in for x in this section. And when we do that, we are going to have 24 plus 12, and the square root of 24 plus 12 is the square root of 36, which is 6. And again, we did that because 24 is greater than 4, or it lies within this section of the function's domain. Now, finding a value of a limit is easy when the value falls within an interval. But what about finding the limit at the point where a piecewise function changes? Such as this example, find the limit of f of x as x approaches 4. Notice that 4 is defined in two pieces. It's defined here, and it deals with this side when you're approaching it from the right. For these, we have to find the limit from both sides and compare their values. So let's find the limit of f of x as x approaches 4. First, we're going to calculate the one-sided limit using the piece of the function that represents values to the left of x equals 4. So that's when -3 is less than x, which is less than or equal to 4. So we're going to substitute 4 in for x in this expression. And when we do that, we would get 4 squared, which is 16, minus 12, which is equal to 4. Next, calculate the one-sided limit using the piece of the function that represents values to the right of x equals 4, or the x values that are greater than 4. So we're going to substitute 4 in for x in this expression, or this piece of the function. So we have the square root of 4 plus 12, which is the square root of 16, which is equal to 4. Since the limits from the left and the right are equal, the two-sided limit exists. So because the limit of f of x as x approaches 4 from the left is equal to the limit of f of x as x approaches 4 from the right, which is equal to 4, the limit of f of x as x approaches 4 is equal to 4. Now let's try another example. We're given that f of x is equal to 5 times k times x for x values less than -3, and it's equal to x squared plus 2kx when x is greater than or equal to -3, or when -3 is less than or equal to x. They mean the same thing. For what values of k will the limit of f of x as x approaches 3 from the right be equal to the limit of f of x as x approaches -3 from the left? This example requires us to apply knowledge of limits. The first step in solving this example will be to set both of our expressions equal to one another. And the reason why we do this is because the goal is for our limits to be equal at the value of x equals -3. Then we have to substitute x equals -3 in for x in all of the x locations that occur. Then we simplify the expressions on each side. So on the left we have -15k, and on the right we have 9 minus 6k, and then we solve for k. So we can add 6k to both sides and get -9k is equal to 9, and then when we divide both sides by -9, we get that k is equal to -1. This means that the piecewise function will be written as f of x is equal to -5x for x values less than -3, and it's written as x squared minus 2x for x values greater than or equal to -3. And the reason why this became a minus 2x is because k is -1. When it's plus 2kx, 2 times -1 is -2.